All right, let's move on with part B. So in the previous part, we went through this expression. I cleaned it up a little bit, so you should probably watch part A if you haven't to figure out how I did this. I found out that the waveform we have right here for the bridge was odd and half-wave symmetric. So that means cosine terms are 0 and the even coefficient of sine is also 0. So the Fourier series should look something like this. And then we found the expression for A of n, solving through it, and we found that that's again 4 VDC times divided by n pi cosine of sigma. And we plug that into the V bridge or the formula right there, and we get this expression. Now, going on for part B, what is being asked of us is to find an expression describing the current in terms of the voltage VDC and LRC omega naught LR. So to do this, we just have to come back up here and figure out how we're going to do this. So what we're going to do is to find out the V bridge is getting taken across this inductor. Make sure that's the inductors first. Yeah, a resistor and an inductor. So a resistor and an inductor. Value R now. So let's find the equivalent, which is R, and the impedance for an inductor is J omega naught L. So we know that the value for the current is going to be what? This is going to be V bridge, right? Because this is our A and B, and V between A and V is going to be our V bridge. Which we found that right there. And we divide that by the equivalent, which is the impedance right there, and that is going to give us a current expression. Yeah. Now let's do that. And what's asking us to find in terms of phase and magnitude, which is something we have to think about on how to do it. So when you do V bridge right there, and when you divide it by the equivalent, so let's do two things for the equivalent. Let's find the magnitude. The equivalent magnitude just becomes real component squared, which is R, plus imaginary component, which is omega L squared. Then we do take the square root of the two. Just simply if you have a triangle, say this is the real part, and this is the imaginary part, omega L, and you want to find the magnitude, which is right here. Then using Pythagoras theorem, you find that's the case. Okay, that was a good review. Let's move on to finding the angle or the phase. The angle is just this angle theta. And we denote it like this, and that is going to be arctangent of the imaginary over real part. So omega L over R. Okay, looks like we're getting closer to being done. I'm just going to incorporate it. So value for average is going to equal to what? The circumference. So we're going to just divide it by that. So it's going to be 4 times cosine of delta whole thing divided by pi. I'm going to put the magnitude for the equivalent, which is r squared plus omega l squared. Okay, correct this millimeter complaint times. Now, how you incorporate the phase is usually theta, write this theta, and write it down inside where you have the angle, you write the phase. So it's just going to be this one up. Actually, move this one up so I can move this up and gives me some space. Okay. Now that's going to be 1 divided by 2m plus 1 times sine of 2m plus 1 times omega naught t. And now, since the theta is in the denominator, we're dividing with, we're gonna subtract theta from it. And we do know what the term theta is the arctangent of omega naught over L. So this is our answer for average. Let me out of the box. So let's see if multiplication is gonna help me. Yep. That's multiplication. Okay, moving on. Let's go to part C. What is being asked from us to use the results we found from part A and B, find an infinite sphere to describe power delivered to the load if one takes into account contribution from all higher order harmonics. Okay, and it's going to give us a hint that says if you have two signs multiplying, sine of n omega naught t and cosine of n omega naught t, we take its integral from 0 to 2 pi equal to 0 if n is not equal to m. Let's move on with this and then see what if it is equal to. So if we have the same integral, let me take care of delete and delete. But what is, so if n is equal to m, what does it become? This is going to give us a 1/2 multiplied by cosine of the angle. It's the difference between the two. So do remember if this was like, instead of having a positive theta, having a negative theta or anyhow that was incorporated with a m term or anything, remember that cosine is an even function. That means cosine of negative theta is equal to cosine of theta. Okay, moving on. We're going to use this hint rigorously in this problem. Okay. Let's see. So to find a power, I'm just going to say the average power, which is how they write down in power electronics, the average. I'll use inside these brackets where okay is equal to 1 over 2 pi. Yes, obviously, sorry. This should be 1 over 2 pi right here, the expression on the right there. Okay, times from 0 to 2 pi times 3 bridge times 5 bridge. And yep. So now we know that the V bridges up here and looks like that, and I bridges like this. Basically, when we do multiply these two, we know they're like different summations. So we're just multiplying some, ignoring everything else. Let's just say it's gonna look something like this: sine of n omega naught t minus 5 for this one, and then sine of m omega naught t and omega naught t, where this is how it's going to look for V bridge, and this is how it's going to look for I bridge. I bridge. And both of them have a 1 over n in front of them, so it's not a big deal. What the big deal is, none of them is actually a big deal. It's pretty easy. So these two terms that have like these different n's and m's, you know, you multiply these two. So what's simple is we can use this form right here. Like these giant terms, suppose you multiply a plus b plus c plus d dot 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 multiplied by like a1 plus b1 plus c1 dot dot dot. And all of that is going to cancel if they're not a. So a times a is going to give us an answer, which is close to like this if I replace a with sine of n omega naught and a1 sine of n omega naught. If these two are equal, they give us an answer. If not, not. So that means the constant terms multiply. So looking at I bridge and V bridge, they have everything in common. So all of that squares, we just don't have a square of the square root of r squared plus omega naught squared. So then let's see, average power is equal to this is a sum, and this is also a sum. So we know that the sum of an integral is the same thing as integral of a sum, right? So since we have a sum of an integral right here, we can go from here to here and write it down like that. So writing the sum, but let me factor out all the constants first, because that way it would be easier. So I know between V bridge and I bridge, I have move this. Okay. 4BC is common. Cosine of delta is common, and as well as phi is common. So what I'm going to do is I'm going to say this squared because it multiplied. And then what is not common is having a 1 over square root of r squared plus omega l squared. Right, and let me clean this up. So I can write data right here. Okay, Now I am going to write the sum. It's right out. This has m from 0 to infinity. I do know this. I have 1 over n and 1 over n, and that gives me a 2m plus 1 because n is always odd. So 2 plus 1 multiplied by. So this 1 over 2 pi times this integral, right? Looking back up right there, you have n omega naught t by sine of, let me replace this with n because I don't have a lot of space. Just remember n is always odd. Okay, so 1 over n squared by sine of n omega naught t times sine of n omega naught t plus minus theta, and it's from 0 to 2 pi, and we know this evaluates to resulting 1/2 cosine of theta when n is equal to m and 0 if n is not equal to m based on the hint. So our final answer should look something like this. Take the easy route and copy some of the data. Okay. And then 2m, sorry, n starts from 0 to infinity of 2m plus 1 squared. And that one is always going to give me a 1/2 cosine of theta. So what I could actually do is write it down right there, even though it's not significant. To factor it outside of this summation, it's going to give me a cosine of theta divided by 2. So, yep, this becomes the expression for this whole thing. Box it, so this is the expression for average power delivered. C. Okay, moving on to part D. Now we're considering the previous part. We're considering the contribution from all the higher order harmonics, but now this question is asking us where to find out power delivered if we only consider the first and the third harmonic. That means the sum is not going to infinity. The sum is just going to from 0 to 1. So let's do this. Average power delivered. All the other terms would remain the same thing. So for VDC times cosine of delta divided by pi whole thing squared times, in fact, out the cosine of theta over 2 cosine of theta divided by 2 times square root of r squared plus omega l squared. And now what we have in the terms is if you plug in 0, you're going to have a 1 over 1 plus plug in a 1, that gives us a 3 right there, so 1 over 9. 1 plus 1 over 9. This term is just going to give us 10 over 9. And we could cancel out this to be 5 and this to be 2. And it makes our final expression a little bit easier. And final expression becomes, okay, let's go away, and then I get rid of all of these, and all I'm gonna have is right here, I'm gonna have 5, and right here, I'm gonna have a 9. So let's box this up. Okay, so that is when we're taking only contributions from the first and third harmonic, and the expression and parsing was for all the harmonics. Okay, now we are officially done with problem A. Let's see. Yep, we're done. We did part D, we're done part that. And see you in problem 2. We're still working on this.